Guys, in our last class we have studied about physical quantities and its units. So there were types of physical quantities like fundamental and derived physical quantities, like that fundamental and derived units. Accordingly, today we will discuss about dimensions. So now you see about dimension. So there is dimension. Actually, dimensions are the powers to which the base quantities are raised to represent that physical quantity. So how you can understand what I say right now? So this one is represented as the powers to which the base quantities are raised to represent that physical quantity is called dimension. So here you are seeing that here you are saying the powers to which the base quantities are raised to represent that physical quantity is called dimension. So now here, how we can understand about dimension? Suppose we have a length. So how you can represent length in its dimension? Actually, length is represented in its dimension by L. Accordingly, your mass is represented in its dimension by M, and all L and M are capital. So now to represent about the dimensions, so here you are seeing about, suppose you have an example 1, that length. So actually the length is represented in its dimension by L. This one is capital L, and then there is a bracket, that would be also capital. Accordingly, I am just taking second example 2. Suppose mass. So this mass is also represented in its dimension by M. So L and M be the dimensions of length and mass. Now accordingly we will see the dimensions of fundamental physical quantities. So here, dimensions of fundamental physical quantity. So the quantity that belongs to fundamental physical quantity, that is, you just make a chart just like that. There is a serial number, and then fundamental physical quantity is there. Then there is units, and then there is a symbol of units, and then dimension. So from here dimensions. So from here accordingly we can get everything is here, that you have a physical quantity, you have a unit, its symbol, and then dimension. Because once you have got the symbol, then it becomes very easy to find dimensions. That's why. So you know you have 7 physical fundamental physical quantities, that is length, second one is mass, third one is time, fourth one is temperature, fifth one is current electricity, sixth one is luminous intensity, and last and 7. So the 7th one is amount of substance. So accordingly, you know the unit of length. You know the unit of length is, because a length is measured in meter, mass is measured in kilogram. Because to find this dimension, you need units. Now time is measured in second, temperature is measured in Kelvin, current electricity is in ampere, luminous intensity is in candela, and amount of substance in mole. So these are the units of all these 7 fundamental quantities. Now then you just write down its symbol. So meter m, kilogram kg small both, second s small, Kelvin k capital, ampere a capital, candela CD small, both are small, and then mole MOL, all 3 are small. Now there is a dimensions, so you have to find these dimensions of these fundamental physical quantities. So because you have symbol meter m, so you know that meter is the unit of length, and length is measured in L. So the dimension of length is measured in length. Accordingly, kg is the unit of mass. This one is measured in capital M in its dimension. Then time, its unit is second, and its dimension is T capital. Accordingly, Kelvin with the unit of temperature and its dimension be either K or theta. Accordingly, current electricity, its unit is ampere and its dimension is either A, its dimension is also A, capital A, or I. Alright. Accordingly, luminous intensity, its unit is candela, its dimension is CD, its unit is CD, candela, its symbol is CD, and its dimension be also in CD. Accordingly, amount of substance, unit is mole, symbol is MOL, dimension be also MOL. Alright, so these are dimensions of all these 7 fundamental physical quantities. Now, using these dimensions, we can find out the dimensions of derived physical quantity. So now accordingly, you just find out dimensions of derived physical quantity. So there is derived physical quantity. So to find the dimensions of derived physical quantity, you must need to remember all these 7 dimensions of fundamental physical quantities like L, M, P, K, theta, K, R, E, C, E and MOL. You must remember. Okay, let's see here. Suppose I wanted to find the dimension of area. You know what? Area having 2 lengths. One be length, other one be breadth. So both are length. That's why its unit be meter square and its symbol be square meter. So how you can make its dimension? You know that meter having dimension L having power 2. So this one is L2. So L2 be the dimension of area. Accordingly, you have to find suppose volume. Now, volume having 3 lengths, length, breadth and height or depth. So this one having 3 lengths. That's why its unit be cubic meter. So cubic meter be written as like that, cubic meter, and its symbol be M to the power 3, that is cubic meter. Now your dimension be L3, it is written as L3. Accordingly, suppose you have density. You know density is mass by volume and its unit we have studied already in previous class. So its units be kilogram divided by meter to the power 3, and then its symbol be kg per cubic meter. This means kg per cubic meter, and then its dimension that will be for kg there is M, and for meter there is L, and its power -3. So ml minus 3 be the dimensions of density. Now in same way, suppose you have a speed or velocity. So for speed or velocity, speed that will be distance by time, and velocity that would be displacement by time, but both having same unit, meter per second. You know, this one is meter per second. So you see here, this one is meter by second. Now in symbol, this write down here is meter per second, and its dimension that will be See here, its dimension B. For meter, there is L. Meter is represented, meter its length represented by L, and per second, so there is time, this one is T minus 1. So LT minus 1 with the dimension of either speed or velocity. And in the same way, suppose you have linear momentum. Linear momentum. So for linear momentum, you know already that this one is the product of mass and velocity. So for mass, there is a kilogram, and for velocity, there is a distance by time. So for distance, there is meter. Because this one is the linear momentum mass into velocity, so velocity for velocity its unit is meter by second, so kilogram meter per second. Now for this one, here you can write down in its symbol kg meter per second, and its dimension is mlt minus 1. For kilogram, m, for meter, L, for time, T raised minus 1. So this one is your dimension. Accordingly, if you wanted to find the now the sixth one, the dimension of acceleration. So acceleration is velocity by time. Velocity is displacement by time. So for displacement there is meter, and divided by time with year. So there is second. So meter per second for its velocity, and then again time. So square of second. Now its symbol meter per square second, and its dimension B. For meter there is L, for time there is T minus 2. So this one is LT minus 2. Accordingly, if you wanted to find the dimension of suppose force. So force is product of mass and velocity. So for mass there is kilogram, and for acceleration meter per square second. So there will be meter divided by second square. Now accordingly, in symbol kg meter per square second. In dimension, for kg m be there, for meter L be there, for time and second there is T be there minus 2. So this one is MLT minus 2. So you are seeing here that force having dimensions MLT minus 2 and acceleration having dimension LT minus 2. So this one is LT minus 2 and this one is MLT minus 2. The dimensions of force. Suppose if someone wants to find the dimension of torque. So torque is the product of force into perpendicular distance. This one is force to perpendicular distance. You know the dimension, you know the unit of force is kg meter per square second. So simply write down that pattern here. Actually this one is formula, so this one is force into perpendicular distance be there, and here you just write down for force. You know, this one is kilogram meter divided by second, and then there is square, and one distance with there, so square is there also. Now in its symbol there is kg square meter per square second, and its dimension is ml to t minus 2. So ml to t minus 2 be the dimensions of torque. Accordingly, if someone wants to find the dimension of energy, so you know the dimension of energy is what? Actually energy, it is come from anywhere. You know, work done is also called energy. So from there you can take that for energy there is force into displacement. So this one is force into displacement. You know, for force, this one will be same, that means kilogram meter, it's square, and then second, again it's square, its symbol is same, kg square meter per square second, and its dimension will be also same, ml to t minus 2. Whatever the energy, suppose you having heat energy, kinetic energy, potential energy, otherwise simple energy, everything having same units, same symbol, and then same dimensions. So you just go on practice to find the dimensions of different physical quantities, because for derived physical quantities there is no limit. We have so many derived physical quantities. So we just keep practicing about this. And now in next class definitely we will see something different.